Hello and welcome to a new video. In this video, we are going to continue talking about variables, and we will start by solving this problem. So if one water bottle contains 0.9 liter of water, okay, and we have 15 bottles, so how much water do we have in total? Okay, so if one bottle contains 0.9 liter for one bottles, and we have 15 of them, the total will be just 0.9 times 15. So let's solve this in Python. So I will start by creating a variable for bottle volume. This will be equal to 0.9, another variable for bottle count, which will be 15. Then a third variable for total volume, and this would be just the multiplication of total volume by bottle count. Now I will print the result by saying the total water volume is, then I will show the content of the variable total volume. So this will be a new argument like this. Then I will add the unit of measurement, which is liters. Now let's run this and see. I will have 13.5 liters in total. So how much do we have in liters if we have 17 bottles? Okay, so now the question asks how much we have if we change the amount of water bottle. So I will come over here and I will update the variable bottle count. This will be equal to 17, now the new value. I have to recalculate total volume. Okay, this will be the same as this, and the result will be shown in the same manner. So I will just copy and paste the code. Now if I run this again, I will have the water volume is 13 liter and the total water volume is 15.3. Now if I want to be more specific, I will update the message to show that the first message is referring to 15 bottle count and the second 17 bottle count. So I will say the total water volume N 15 bottle is, or a better idea is to write it like this. So instead of 15, I will do the following. So I will close the code here and open a new code here. And in between, I will add the variable bottle count. So now I will print the total water volume N, then the content of this variable, bottle count, then the word bottles and the word is. Then I will continue as before. So let's update also the second statement by copying and pasting the message. Now I have better message. Now notice here that I changed bottle count, okay, from 15 to 17. However, the amount of water in one bottle is still the same. Okay, this is what we refer as a constant in programming, where a variable will not change value throughout the program. So the value of this variable will stay constant. And in Python, to show that this variable will stay the same, we write it in all capital letters. Bottles. We use underscore to separate words if the variable name contains more than one word. So I will take this and I will update the formula, total volume equal bottle volume. Sorry, this should be bottle volume. So take bottle volume, put it here, and right here. Okay. Now if I run this again, the exact same result. So the only thing I changed is I emphasized that this variable here will not be changed by writing it in all capital letters. And this is what we call a constant variable. Okay. So a constant is a variable that will not change in the program. We use all capital letters, so it looks different. Okay, so Python does not enforce that this variable will be constant. You can change it if you want. However, the convention is whatever you write in all caps, it will still will stay the same throughout the course of the program. And if the variable name, which is a constant, contains more than one word, you would use underscore to separate the word. Okay, let's solve this problem as well. We have a store that sells 6 packs of soda for the same price as 1 bottle. And we know that 1 can in the 6-pack contains 12 ounces and the bottle contains 2 liters. So 1 can equal to 12 ounces. However, 1 bottle here contains 2 liters. So I want to know what option should I buy so I have more to drink. So I will first of all convert the unit. So 12 fluid ounces will be 0.3355 liters. After I convert the unit, I will do the multiplication. So this is the capacity of 1 can. So for 6-pack, I will multiply this by 6. And I will compare it with 2 liters to know what should I buy. So let's do this in Jupyter. I will create a variable for the volume of 1 can. This is a constant variable because I'm not changing this amount throughout the program. So can volume equal to 0.355. And I will say also a liter, sorry, bottle volume is 2 liters. Now, for the amount of cans in the basically 6-pack, I will write a variable called cans per bag equal to 6. You can argue that this is a constant instead of a normal variable. And you can argue also that my program will be generic for any size of pack. Okay, so this can change in the program. So I'll have it as a normal variable. Either way, it's correct, whatever you assume. So cans per bag is equal to 6. Now I will calculate the total cans volume. So total cans volume. This will be how much soda do I have in the 6-pack. This will be cans pack multiplied by can volume. And now I will print both. So I will print total soda in 6-pack equal to total cans volume. And I'll add the unit of measurement, liters. I will also print total soda in the bottle is, and I will print here the content of the constant variable bottle volume. We'll add the unit liters. So when I run the code, I see that I have, sorry, there is a spelling error somewhere. Yes. Okay. Total soda in 6-pack is 2.13 liter. Total soda in the bottle is 2 liters. So to have more to drink, we should buy the 6-pack for the same price. Okay. So here we have a recommendation. So to calculate total volume or total cans volume, you can multiply cans per bag by the number 0.35. However, this is what is known as a magic number. In your code, if you have a number like this has no explanation. Someone is reading your code, he does not know or she does not know what this number is referring to. However, a better practice is to store this number inside a variable called can volume, then use this variable in your calculation. So now when someone sees this calculation, they understand that you are multiplying the number of cans per one can volume instead of just a number which is 0.355. Okay, now we will discuss something about undefined variables. So let's have an example and explain it in Jupyter. Assume I create a variable A, which is equal to 3, then a variable B, which is equal to A, then I create a variable C, which is equal to 4, then I update C by assigning Y to it. Now I want to print the variable C. Now, if I run this, you see I have an error. Name error, name Y is not defined. So let's explain what is going on here. You have your memory right here. And when you execute the first assignment statement, remember that any assignment statement will start from the right-hand side. So you will store number 3 inside a variable A. So take allocation in memory, give it the name A, and store the value 3. Now we are finished with the first statement. For the second statement, you'll start from the right again. You read A from memory. So A has the value 3, and you will store it inside a variable named B. So you create B, store inside it 3 again. Third statement, you have 4 stored in a variable called C. So you create a memory location, name it C, and put 4 in it. Now the fourth assignment statement, you will start from the right again. You try to read the variable Y from memory. You go to your memory and you search for the variable Y. There is no variable Y inside the memory. This is why you have this error. Y is not defined. Okay, you are using a variable, okay, before defining it, before giving it a value, which is not allowed in programming. So that's it for variables. And I will see you in the next video.